Hello friends, today we shall learn how to find the inverse of a matrix using elementary row transformation or column transformation. First of all, we take some examples on the elementary transformation. Apply the given elementary transformation on each of the following matrices. First example, here it is the transformation R1 interchange with R2 on the matrix A. That means here only R1 interchange with R2. That means position of R1 takes R2 and R2 position of R2 takes R1. That means here, let us note here in this way. Second operation, R1 interchange with R1 minus R2. That means here 1 is replaced by 1 minus 2. Minus 1 is replaced by minus 1 minus 5. 3 is replaced by 3 minus 4. That means here 1 minus 2 means minus 1 minus 5 minus 6, and 3 minus 4 is minus 1. Third example, on the P matrix, here it is on two operations here. First operation column and second it is a row operation or row transformation. Let us given P matrix, then I by C3 interchange with C3 plus twice C2 gives here C3 plus twice C2. That means 3 plus 2 into minus 1, 0 plus 2 into 1, 1 plus 3, 2 into 3 as it is. This is the required matrix. Now we apply next operation 3 into R3. That means multiply third row by 3. That means 9, 9, 21. Next example, transform given matrix 1 minus 1 2, 2 1 3, 3 2 4 into an upper triangular matrix by suitable row transformations. Solution, let us denote it by A. First of all, apply the transformation on the given matrix R2 minus 2R1 and R3 minus 3R1. We get here R2 minus 2R1. That means 2 minus 2 into 1, second 1 minus 2 into minus 1, and 3 minus 2 into 2. Next operation R3 minus 3R1. That means 3 minus 3 into 1, 2 minus 3 into 2, and 4 minus 3 into 2. And we get here required matrix 2 minus 2 0, 1 minus 2, that means 1 plus 2 3, and 3 minus 4 minus 1. Here it is 3 minus 3 0, 2 plus 3 5, 4 minus 6 minus 2. Now next operation R3 minus 5 by 3 R2 we get. And which is equivalent to the, therefore A is equivalent to the, by performing these two operations, this is the upper triangular matrix. That means here below the diagonal elements are 0. Next example, to find the inverse of a matrix elementary using elementary row transformation. This is the 2 by 2 matrix. First of all, we check whether it is invertible or not. Let us given matrix A. Now therefore determinant of A is equal to 3 plus 2 is equal to 5. That means non-zero. Therefore A is invertible matrix. Therefore A inverse exists. Consider, for that we consider A into A inverse is equal to identity matrix. Now our task is to make left hand side matrix into identity, and therefore by R2 minus 2R1 we get here as it is. Next operation 1 by 5 R2 we get. Next R1 plus R2 we get. Therefore identity matrix into A inverse is equal to required matrix. Further one can easily common outside taken 1 by 5. This is the required inverse of the matrix. Now next, to find the inverse of the matrix using elementary column transformation, first we denote it by this matrix by A. Now we check whether it is invertible or not. Consider determinant of A is equal to cos square theta plus sin square theta is equal to 1, which is non-zero. Therefore A inverse exists. Now for that, here it is the column transformation we take here. Consider A inverse A is equal to identity. Similarly, we can convert this matrix into identity. First operation here, cos theta into C1. That means multiply cos theta to the column C1. We get as it is. Multiply cos theta into C1. Now multiply sin theta into C2 and subtract this element from column C1. We get here as it is. This will equivalent to the matrix. Now we apply the operation C2 plus sin theta into C1. We get next operation, divide cos theta to the column C2. Similarly, divide cos theta to the column C2 and we get here given matrix. This is A inverse into identity is equal to, therefore A inverse is equal to cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. This is the required inverse of the matrix. One can easily verify by multiplying A inverse into A as it is. A inverse left hand side, A to the right side. Now we multiply first matrix to the second matrix. First row, first column. Cos square theta plus sin square theta is equal to 0. First row, second column. Here it is as second row, first column. Second row, second column. Second row, third column 0. Third row, first column 0. Third row, second column 0. And third row, third column 1. And which is equivalent to the matrix identity. This verifies the inverse of the matrix. Next, similar student can easily find the inverse of the matrix by using as it is above. Thank you.